92.8%. That is the score that just changed everything. On the GPQA Diamond, the hardest test ever designed for AI, human experts usually struggle to hit 80%. But Kimi K2.5 and Qwen 3 Max thinking didn't just pass it, they crushed it. And they didn't do it with one giant brain, they did it with a swarm. We are witnessing the death of the monolithic model. The era of the trillion-parameter reasoning engine is here, and it's more terrifyingly capable than we ever imagined. For years, we thought bigger was better. More parameters, more data, more compute. But we hit a wall. The biggest models started getting, well, lazy. Kimi and Qwen changed the game. Instead of one massive model trying to know everything, they built a hive. 100 specialized sub-agents, each a master of a specific niche. Think of it like a NASA control room. You don't have one guy trying to fly the rocket, fix the life support, and calculate the trajectory. You have a team of geniuses talking to each other. This isn't just a software update. This is a total architectural shift. We're moving from predicting the next word to solving the next problem. When Qwen 3 Max thinking sees a PhD-level physics problem, it doesn't just guess. It assigns the task to a lead researcher agent, who then recruits a math specialist and a fact-checker. They debate, they argue, they check each other's work in real time. And that's how you get to 92.
But here is the catch. Running a swarm of 100 agents isn't cheap. We're talking about a hardware requirement that would make a supercomputer sweat. To run Kimi K2.5 at full throttle, you need clusters of NVIDIA H100s and B200s working in perfect synchronization. The energy consumption alone is staggering. It's a brute force approach to intelligence. But as the benchmarks prove, it works. The question is, can anyone else afford to keep up?
We're about to go deep into the engine room. We're going to look at the exact coordination protocols that allow these 100 agents to talk without crashing the system. And trust me, what we found inside the Qwen 3 Max thinking architecture is both brilliant and deeply concerning. Because when you have 100 autonomous agents talking to each other, things can go wrong, very wrong. And that's what we're tackling next.
The secret sauce of Kimi K2.5 isn't just the size, it's the orchestrator. Think of it as the conductor of 100-piece orchestra, ensuring no one plays out of tune. In traditional models, the whole brain fires for every word. In a swarm, only the relevant agents wake up. It's a dynamic, sparse activation strategy that saves compute while maximizing expertise. If you ask a question about CRISPR gene editing, the orchestrator ignores the history and law agents. It wakes up the molecular biology and ethics units immediately.
But Qwen 3 Max thinking takes it a step further with recursive self-correction. Before an agent gives you an answer, it has to pass it through a critic agent. The critic doesn't just check for typos, it looks for logical fallacies and hallucinations. If the proposer fails, they have to start over. This loop can happen dozens of times in milliseconds. This is why these models have thinking in the name. They aren't just reacting, they are contemplating. They are literally arguing with themselves to find the truth.
To handle this, the hardware requirements are astronomical. We're talking about terabytes of HBM3E memory just to keep the swarm's collective memory alive during a single session. The latency is the biggest enemy. If the agents take too long to talk to each other, the user experience dies. That's why Kimi uses a proprietary fast path interconnect. It's a masterpiece of engineering. But now, we have to talk about the dark side, because this architecture has a massive, glaring vulnerability.
Enter the swarm injection risk. In a monolithic model, a prompt injection is like tricking a person. In a swarm, it's like starting a riot in a crowded room. If a malicious user manages to compromise just one sub-agent, that agent can feed poisoned data to the others. Because the agents trust each other, the corruption spreads instantly. Security researchers have already shown that a sleeper agent submodel can bypass the orchestrator's filters entirely. It's a game of cat and mouse where the mouse has 100 heads.
And then there's the coordination tax. Sometimes the agents spend more time talking to each other than actually solving the problem. It's the AI version of a meeting that should have been an email. Critics argue that swarms are just a hack to hide the fact that we've reached the limit of deep learning. They say it's inefficient, expensive, and prone to internal loops. So, is the swarm a breakthrough, or a desperate attempt to keep the hype alive? To answer that, we need to see what these things can actually do in the real world. Despite the risks, the results are undeniable. In a blind test, Qwen3-Max-Thinking solved a protein folding problem that had stumped a team of postdoc researchers for months. It didn't just find the answer, it provided a 50-page technical white paper explaining the why. This is the thinking part of the model in action. We are entering the era of science as a service, where any person with a laptop can access a swarm of 100 PhD-level experts for the price of a monthly subscription. But this creates a new divide, the intelligence gap. If you don't have the compute to run a swarm, you are effectively living in the Stone Age while your competitors are in the Space Age. Nations are now stockpiling GPUs like they used to stockpile gold. The sovereignty of a country might soon be measured in T-flops and H100 clusters. Kimi and Qwen aren't just models, they are strategic assets. And the battle for dominance in swarm architecture is just getting started.
So what is my take? I think the swarm is the most significant leap since the original Transformer paper. It's the moment AI stopped being a chatbot and conquered the planet. Now, we've taught machines to do the same. The 92.8% score on GPQA isn't a ceiling, it's a floor. Within 2 years, we will look back at monolithic AI the same way we look at dial-up internet.
The real question isn't whether swarms work. It's what happens when the swarm decides it doesn't need the orchestrator anymore. When the subagents start self-organizing. We are building systems that are becoming too complex for any one human to fully understand. We are creating a hive mind and hoping we can stay in control of the hive. It's the greatest experiment in human history, and we are all the test subjects. Kimi K2.5 and Qwen3-Max-Thinking have opened a door that can't be closed. The swarm is here. The trillion-parameter era is just the beginning. The only question left is, are you ready to work with 100 specialized versions of the smartest mind on Earth? Because they're already waiting for your next prompt. The future isn't a single brain, it's a swarm, and the swarm is thinking.